so that way you could go back and look at this as needed. Awesome blossom. So you've all made it clear that you don't want to work out with me. That hurt anybody who just got here late. Anybody who got here late and says, hey, I'll work out with you, can you just give me a thumbs up or a shout out? Okay, great. That hurt my feelings so much. It hurt a lot. Why isn't it on here? Okay, so just give me a second to not share screen real quick. I don't know why it's acting up, but this is what I wanted. And now we can go back to you guys and go here and go back to sharing my screen. And here it is. Okay. All right. So curious. What are some things you guys can annotate? So why don't you annotate on this screen things that you know about an inverse? So you could type it via text, you could type it via anything. Remember, you can go up to the top here where it says options and it says annotate. So at this point, I don't care if it's repetitive, I don't care what it is, but everybody should be putting something up there that they know about a function and its inverse. So that is what we are going to do for the first couple of minutes before we move on to the next thing. Remember, if you do a text box, you can actually type. Whoever said has to pass the vertical line test, that's if something is a what? Awesome. Whoever put has to pass the vertical line test, that's if it's a function. Be careful if you want it to have an inverse, it's not the vertical line test, it's the, thank you. So make sure whoever has this up here, this I want fixed. So whoever typed that in, go back and fix it. Okay. How do you find an inverse? How do you find an inverse? If you wanted, somebody wants to type that in there, because we'll go over a couple of these things here. I like what I'm seeing, by the way, so far. All right. Okay, so here is some stuff here. So it says opposite operations of a function. F of g of x has to, I like that. Whoever said that, that's really good. I can admit Chantel, if she comes, awesome. Okay, so when we talk about, let me go here. I can put my little pen here. All right. So who put points on the graph are also inverses? Who said that, and what do you mean by that? And can we have a conversation about that? Points on graph are also on inverse. What does that mean?
I said that.
Yeah, what did you mean by that, sweetheart?
Then when you like graph it on Desmos, that the x and y's are flipped.
Okay, so so basically what you're saying is that whatever is going to be on, if you have the point 2, 3, you know on the inverse the point is going to be 3, 2. Is that what you were trying to say? Okay. So opposite operations of a function. So who said opposite operations of a function? What do you mean by that?
I said that. So like if you have like addition, to find the inverse, you do subtraction. If you have like multiplication, you use division.
Awesome. Whoever put reflects over the line y equals x, bravo. Who put this in here, that f of g of x has to equal x and g of f of x has to equal x? Who said that? One of you typed it. Who typed it?
I did.
And why did you say that? What do you mean by that? What does this mean, sweetheart? You're right, but what does it mean?
When you put in, like, for the first one, like f of g of x equals x, that's for like every x in like the domain, because like the basically like the inverse of the function, like if you put that into the regular function, like it'll equal x. if you
Okay,
solve
so in
it.
other words, does it make sense that if you take an inverse and plug it into its function, it should bring you back to where you started?
Yeah.
Yes, right? So, and then it's saying that g of f, if you do it the other way, it should still bring you back to where you started. What does this actually show, everybody? If I show that f of g of x is equal to x and that g of f of x is equal to x, what does that automatically tell me? What does that tell me about f of x and g of x? What are they? F of x and g of x are?
Equal?
They're not equal. What are they?
No.
Not that they're equal, but
Opposites?
they're not opposites. Use the better word, that f of x and g of x are
Inverses?
inverses. Yeah, they are inverses. This is saying that they are inverses of one another. That's exactly what it's saying. That if I can go ahead and if I plug some function into another function and it spews back in x, and if I do it the other way and it spits back in x, it's telling me that it got back, I can get back to where I started, and therefore I can say f of x and g of x are inverse functions. Very good. Yeah, let's go over here. You can, to undo a function, you use f inverse of x, and it has to pass the horizontal line test. Exactly. Which brings me here. Who put quadratics can't be used in an inverse function unless you restrict the domain? Who said that? Somebody put quadratics can't be used in an inverse function unless you restrict the domain. Who said that? One of
Me.
Who is me?
Me.
Good.
Jackie.
Good. So Jackie, can you give me, so in other words, what do you mean by that?
So it has to pass a horizontal line test, so there can't be, like, for each y value, it can't go through the line more than once.
Exactly. So we can see, uh-oh, it's hitting the line twice, which is why we can pick the right half of the parabola, or we get to pick the left half of the parabola. Is everybody okay with that? Yes, nod your head. Awesome. Okay, so there's a couple of things there. And that's when we restrict the domain, we are able to make the function one-to-one. So whoever said one-to-one, yes. So for every x, there's always one y. So here's what I want you guys to do. So can you all erase your beautiful stuff here that you have on the screen? Can everybody go in and erase everything that they have on the screen? And then we can take it from there, okay? All right, so whoever left, you can make a function one-to-one by restricting the domain. Please get that out of there, okay? Thank you. All right, if your name, if your last name is from A to F, you're gonna do A, okay? And for everybody, so for each grouping, you're gonna find the inverse for each function. You're gonna sketch both functions on the same XY axis. You're gonna show that the function is an inverse, reflects over the line. Actually, what I wanna say is, I don't like how I worded that, forgive me. I sketch both X and Y, blah, 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 blah. So on number 3 instead, hold on a second. On number 3, I want you to show that f of g of x, f of g of x, the inverse, that the inverse, so f inverse of x is, whatever. All right, Charlene, breathe. Everybody say Seashwa, breathe.
Breathe.
Okay, so you want to show that f of f inverse of x is equal to x, and that f inverse of f of x, my drawing is equal to x. So here's what I want to say. So before we do that, though, before I assign this to everybody, I just want to make sure, do we all know how to find an inverse? Do we all know how to find an inverse? So if I have like, f of x is equal to, let's say, the cube root of 2x plus 1. What's the first thing I'm going to do here? Can somebody like Luca Doozy, can you tell me what I do first?
Well, you could switch that, like, you could make it equal to x. That's the way you could do it. So, like,
well, the first thing you need to do is change f of x to
y.
Y.
y. Good. We're going to change that to y first, right? And now we have y is equal to 2x plus 1, right? So that's the first thing we want to do. What's the second thing we want to do?
Put it to the third, like third power.
Absolutely not yet,
the,
because right now this is still the same function. It's still the same function, right? What do we know about a function and its inverse? What did we say about the ordered pairs? We say that what happens to the x's and the y's, everybody? They
Switch.
switch, right? So literally right here, what do you think we're going to do here? We are going to
Switch the x and y.
switch the x and the y, exactly. So now this is going to be your 2y plus 1, because that's how we're going to find an inverse. We actually switch x and y, because that's literally what happens to the x and y, is that they switch. So now I'm here. So now, Lindsay, what am I going to do from this point if I want to solve for y? Because we switch x and y, and we solve for y.
And after this, is this when you put it to the third power?
Well, here, yeah, because we're trying to solve for y. So let's use our heads. Like, we have to use the inverse operation of the cube root of something, right? So what is the inverse of the cube root of something?
So the inverse of the cube root of something is to the third power?
Yeah, so we're going to literally cube both sides, right? So does somebody have a marking over here that they left? If they can you get it out of there? And then this is let me just put this in here, make it look a little bit nicer. So just to make you guys feel a little bit better. So yeah, so this is going to be the cube root of 2y, and that whole thing cubed, right? So the cube root of something cubed, what happens to the right side? What are you going to be left with there, Jillian?
Sorry, I didn't realize I was on mute. It's 2y plus 1.
It's just going to be 2y plus 1. Very good. Okay. So now, because the cube root of something cubed, that's the whole point. An inverse undoes the other thing. So now the next step, Lucas, is to do what?
You subtract the 1.
Subtract the 1. And then finally, everybody, we
Divide by 2.
divide by 2. So that's going to be equal to y, which means that this represents the inverse. So this is the inverse function, is x cubed minus 1 over 2. So when I go back over here and I look, let me use a different color. Tell me that my internet's unstable. I don't have time for that. Okay. All right. So this is my original function right here, right? The cube root. And then this is f inverse of blah, 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 right? So one of the things that we can show is there's a couple of things, and then I want you guys to do something is we want to show them that if I do f of f inverse of x, you know, I want to show that that's equal to x, but I also want to show if I do it the other way, right? If I do it the other way, that's also going to spew an x. It has to work both ways in order for the inverse to be true. So f of x, the original function, if I remember, was 2y plus 1. Is that right? Hello? And then I think this was x cubed minus 1 divided by 2. Okay, so then x cubed minus 1 divided by 2. So now if I'm going to do this, right, this should be an x there, not a y. What am I doing? Okay. All right. Sorry about that, guys. That should be an x there. You should have all called me out for that immediately. So this was the original function, and we're saying that this is the inverse function, right? So two things. So in other words, if I want to show and prove and confirm that they are inverses of each other, I want to show that f of f inverse of x is equal to x, which means I'm substituting the inverse, which is x cubed minus 1 over 2. And you should be doing this and following along with me, is equal to, you know, x by the time it's all said and done. So basically, I am taking this whole monster and I'm plugging it right in for that x up there. So that's why we're going to do the cube root of 2 times, we have x cubed minus 1 over 2, and then plus 1 inside the parentheses. And then you should all say, oh, look, the 2's cancel, and we get the cube root of x cubed minus 1 plus 1. The 1's cancel, and then I wind up with the cube root of x cubed, which is x. So I have actually verified that, okay? Now, if we go the other way, and we want to do f inverse of f of x, so we're doing f inverse. This time we're going to do the cube root of 2x plus 1, right? We're going to substitute this in for x in the inverse function. So everywhere I see an x over here, I'm substituting this monster in, okay? So now f inverse of, so in other words, that's just going to equal f inverse of x is going to be equal to the cube root of 2x plus 1. That whole thing is cubed because that was the x minus 1 all over 2. And again, The cube root of something cubed undoes itself, so you wind up with 2x plus 1 minus 1 over 2. You cancel out your 1 and your negative 1, and then you get 2x over 2, which does equal x. So we legitimately just verified that those two functions are inverses of each other. Now, the other thing is yeah? Did somebody have a question? Did someone have a question? Hello? Okay. So the other thing is that you can show that if you were to graph these two functions on Desmos, they're going to reflect over the line y equals x. Is everybody okay with that? Okay. Now, I'm going to go back to what I wanted to do with you guys. And over here, you guys now, your job for the next 8 or 9 minutes is, let's do this, is you're going to, I don't like what I have here on here, so I'm going to make you guys fix it for me. So instead of number 3, show that the function in its inverse reflect over the line y equals x. I want you to show that you get x when you do the composites of those. So I don't need you to show that they reflect over the line y equals x. We can go ahead and do that on Desmos when we're ready to. Okay, so if your last name is from A to F, you're doing A. If you're from G to K, you're gonna do B. If you're from M to R, you're going to do C. And then if you're S to W, you're going to do D. Okay, so does everybody know what letter they are doing based on their last name? Hello, is this thing on? Good. Go and do that. So you guys are going to work. So you're going to find the inverse for each function. Okay, you're going to sketch both functions on the same XY axis if you want to. So and if you you should be able to do it by hand, but if you want to go in Desmos and verify all that, you can. And then you have to show that f of f inverse of x is x, that the composites are both going to spell out an x. And then the last question I ask you is, at what point did the two functions intersect? I want to know the answer to that algebraically. Not just using Desmos, because I know that we all have a little bit of a, devotion to Desmos, but I want you guys to be able to figure that out yourselves. Okay. And I want to say, Jace, thanks for getting here. Who else popped in late? Michael, thanks for getting here.
Dishwa, I'm in here too.
I saw you get here, Chantel. I saw you, baby doll. I'm glad
Sorry for being late.
It's okay. You made it. Listen, you made it. That's the important thing. That's what I'm looking for. Okay, is that you guys actually made it. That means the world to me. And just keep working on this, because I would like to go over it, possibly before the end of the period, and then, take it from there. How we doing, kids? Great. Thanks for the, there you go. Low response. Much appreciated.
I'm done.
You're done? Who said I'm done?
Lucas did.
Lucas, what number what letter did you have to do?
I did C.
Okay, so can you do the inverse for us? And you can call it H inverse of X. Can you just give us what the answer for H inverse of X is?
Of course.
Is anybody done with A yet? Does anybody have an inverse for A?
I have number 1 done for A.
Okay, good. Let's put it up. Who has B? Who has the inverse for letter B? These are all linear functions, gang, so I think that we should all at least have the inverse for each one of these because we're a little tough on time. So, and I have B. And somebody put up B and somebody put up D for me.
I'll do B.
Whoever said I'll do B, I appreciate that. Lucas, you put up the X minus 3 over negative 6?
Yeah, X minus 3 over negative 6.
Okay. So that was, so I'm going to come in here so I can write because I'm the best. So we can say that F inverse of X for this one is equal to X plus 7 over 2, right? And then does somebody have G inverse of X over here? So then you have H inverse of X is equal to X minus 3 over negative 6. We're going to clean that up. I don't like there's a negative 6 down there. That bothers me. And then you got G inverse. The inverse is, okay, so then G inverse of X is equal to negative 3X plus 3. All right, so these should be the inverses for, that's A, that's B. Here is C, which I'm not in love with. I would like to see it as this. Like that. See what I did there?
Oh, yeah.
Did everybody see what I did on C? And then here, K inverse of X is equal to 2X plus 4. I don't, did everybody get 2X plus 4 for this one?
No, I made a mistake, but I don't know how to delete it.
So, well, you just deleted it. It's gone. So can you fix it?
Yeah.
All right.
Yeah, it's just minus.
It's what?
It's minus 4.
It's minus 4?
Yeah.
So you switched X and Y, right? You subtracted 4. Right? So you're saying this is 2X minus 4?
Oh, minus 8.
Minus 8. Okay, so I was going to say it doesn't feel right when you're doing it. I think it should be. Who did D? The people, all of my S through W, did you all get 2X minus 8 as your inverse? You're killing me, you guys. You're killing me. Anybody who was S through W, did you get 2X minus 8 as your inverse? Because if you didn't, we can certainly go over it.
I made the same mistake and had 2x minus 4.
Right, so if you have X over 2 plus 4 is equal to Y, when you started off with, guys, you got to watch your algebra. Remember, we switch X with Y, right, is equal to X. So now the first thing you're going to do to both sides is? Anybody? You're going to? You're going to subtract 4. You bet you are. So you have Y over 2 is equal to X minus 4. But now you have to multiply everything by 2, which is Y. This becomes Y equals. So you actually have to make sure both of these are doing that. So that's why you get Y is equal to 2X minus 8. Okay? Now, what I'm going to have you guys do for me is, since we are out of time, it is already late. What I would like you guys to do, and I will specify this, that by tomorrow, I'm going to go back here. I'm going to ask you guys by tomorrow to have 2, 3, and 4 done for whatever one it was that I assigned to you. Okay? So did everybody understand? We only went up, we went over number 1. We all agreed that with that these are the respective inverses, but then you guys are going to finish by doing 2, 3, and 4 and having that due by tomorrow. Okay? All right, friends? So I'm going to stop sharing. And
Wait, do you mean 2, 3, and 4 for all of them, or just the one?
No, just the one that I assigned you. Just the one that I assigned you. If you want to do extra because you think you need to practice, then take the initiative. But I just need you to do it for the one that I assigned you. So, but if you wanted to be like, okay, I think I could use the practice, I'll do it for one more problem. Wow, wouldn't that be awesome if you took the initiative on that? But no, I just need you to finish 2, 3, 4. Okay? But boy, would I be excited. And you know what might be happening down the pike is Mama Schwa might be that evil wizard who says, we're going to have a pop quiz when we meet live. And I'll be assigning certain problems to certain people, and then you'll have to upload those like to email or to Canvas immediately. So just keep in mind that I'm going to be keeping you little beautiful beings on your toes. Okay? So you get to work on your videos today. And again, you have to finish 2, 3, and 4 for me, and those are going to be due by tomorrow. Okay?
Okie dokie.
And I'm here if you have questions. I like that you guys reach out to me via Google Hangouts or Remind if you have questions. So please keep doing that because I love that you do that. And just anybody who showed up late, if you're into working out with me at 2 o'clock tomorrow, I will see you at 2. I posted the Zoom thing at the top of Canvas for that 2 o'clock workout. Anybody who showed up late thinking they might show up at 2 and do a workout with me, because you don't need weights, by the way, but if you have weights, we can use them. Jace, no, you don't want to work out with Schwa. D'Onofrio, you don't want to work out with Schwa. Lucas? No?
Perhaps.
Sanaz? Rebecca? Cole? Megan? Grace? We can sing through it. Well, I'll be gasping for air. We can manage, you know? But think about it. You might be surprised. And yeah, so we'll take it from there. And let me just close this off because then I can stop recording.